Hello friends, today I am going to discuss about solubility. Solubility is a term which is related to the solution, and we know that solution is something which is a mixture in which we generally study about the binary solution which has solute part and the solvent part, and solubility depends on the amount of solute. So before going further, I would like to tell about the solution. Solution is actually having two parts, that is solute plus solvent. So if we take the example of sugar dissolved in water, then the solute will be considered as sugar and the solvent will be water. So here we are studying about the solubility. Solubility depends on the amount of the solute present in the fixed amount of solvent at a fixed temperature, and solubility is directly proportional to the solute or the amount of solute. It means as more as solute is present, the solubility will be the more. So as the definition we can say that solubility is the amount of solute present in a fixed amount of solvent at a fixed temperature. We can take solubility in gram or kilogram. So here we are just going to discuss about the solubility of gases in liquid. We know that water is a liquid and oxygen, carbon dioxide and some amount of nitrogen is also present in water. So we can say that that is a solution because there are two chemical formulae dissolved physically dissolved, actually not chemically, because this is the main part of the solution. Solution is something in which the amount of solute dissolved with solution in physical terms, not in the chemical terms. So for discussing about the solubility of gases in liquid, there are few factors which affects the solubility of gases in liquid. First is nature of the gas. Gas means, again, this is the kind of thing which we can say that the how many kinds of physical force or what type of physical force is in between the gas and the liquid. So more is the force of attraction or intermolecular forces of attraction, the greater will be the solubility. Second part is nature of the solvent. Nature of the solvent means, again, this is the thing which we can say that if solvent is polar and the solute is also polar, then the solubility will be more, which we'll discuss later on as well. Or we can take the one example here. Suppose we are having water as the solvent and C2H5, just a moment, and we have O2 gas dissolved in water. Then we know that oxygen is a non-polar gas, and compare then CO2, this is non-polar, more non-polar. So due to this factor, the solubility of oxygen at the fixed temperature will be less than the carbon dioxide in water due to the different nature of their dipole moment. Temperature, that is the third factor which affects the solubility of gases. Temperature is also inversely proportional to the solubility of gases. This is the main point, very important point. We need to learn that if gas is dissolved in the liquid, then the temperature will be inversely proportional to the solubility of gases in the liquid. Third point is pressure. Pressure is directly proportional to the solubility of gases. As long as pressure is applied, as much as pressure is applied, the amount of gases will increase in the solution. So now we are just going to discuss a very important Henry's law, which is study for the solution of gases and liquid, in which we say that, as we know that gas pressure is the main part of the gases or main character of the gases, so that as much amount of the gas is present in the solution, the pressure will be more. So we can say that pressure is directly proportional to the pressure will be directly proportional to the amount of gas, and here the amount of gas is taken as the mole fraction of the gas. And if we remove the proportionality sign, then pressure will be equals to kh and chi. Here kh is the Henry's constant. This thing we can also understand by seeing this graph. In this graph we can clearly mention that we can clearly understand by this graph that mole fraction of the component in the solution. Here we are discussing about the gas in the liquid. So mole fraction present in the component mole fraction of the component present in the solution is directly proportional to the pressure, because we are having a straight line graph which shows that as pressure is increasing, mole fraction is directly increasing. So the formula is proved here. P is directly proportional to mole fraction of the gas present in the solution. What are the application of Henry's law? We can take the example of soft drinks or soda water filled in the bottle, in which CO2 is passed with high pressure to increase its solubility. Second example is during the sea dive, the O2 is going less and less in our body, and then we feel pain because due to the less amount of oxygen there will be the bends, or we will have the breathing problem. Third is high altitude. At high altitude, the partial pressure if O2 is less than at the planar area or the ground level. This leads to low concentration of O2 in the blood pressure of climber, which causes anoxia. Thank you very much for watching the video.